Okay, this is the P3 paper from January 2021. It's question number 7. And if we take a look at this, we can see this is a big trig question. We've got proving trig identities in here. We've got some work on double angle formulae. And it looks like we're going to have a trig equation to solve at the end as well. So let's make a start. The first one says, can we prove this? So let's write it down. For part A, I'm trying to prove that sine 2x over cos x plus cos 2x over sine x is identical to cosec x. So pretty obvious, we're going to choose the left-hand side, and we're going to try and make the left-hand side look like the right-hand side. I can change that pretty quickly to 2 sine x cos x. I can change that. Now I can change that to cos squared minus sine squared, to 1 minus 2 sine squared, or to 2 cos squared minus 1. I've got a choice of things to do there, and I'm going to choose the one that has sines in it, purely sines on their own in it, because I'm dividing by sine x here. So my next line down, I've not really got any choice. The sine 2x. Sine 2x is 2 sine x cos x. Okay, so I've just changed the top one there. Now changing the numerator of the other term, as I say, I've got a choice of things, but I'm going to choose 1 minus 2 sine squared x simply because I've got a sine x in here. Now, if that's wrong, I can go down a little bit, see that it's not working out very well, and then change it to something else. Let's do the next line, because the next line hopefully will make sense here. When they cancel, and I end up now with 2 sine x over 1 minus 2 sine squared x all over sine x. Yeah, now I can see that was the right decision to make. Actually, it was more important that this was sine x than that this was sine x, because now all I've got on my left-hand side is sine x's. So at this stage here, pretty confident with this is going to work out. Now, I don't know the exact answer, but I always know if I do that, I can now cross multiply and get a simplified fraction from there. So that's not causing me any problems. That's going to be now 2 sine squared x, that times that, plus 1 times all of the other bits, so 1 minus 2 sine squared x all over sine x there. And then looking at that top line, that's going to cancel with that. So I'm going to end up with 1 over sine x, which is then cosec x, which is then identical to cosec x. So we've managed to prove it there, because it's equal to the right-hand side and the left-hand side are equal to each other. Okay, hopefully that makes sense to you for the first part. Part B then. Let's go back and look at the question here. So what we're noticing with part B is that this bit here is very similar to that bit there. In fact, if you say that x is equal to 2 theta, then it's the same as it, isn't it? So I'm going to be able to replace this bit with cosec x there. That's going to be replaced with cosec 2 theta, okay, because that's 4 theta and 2 theta and 2 theta and 4 theta there. But now that absolutely means I should be able to get started with that question. So let's do that first of all. So we've got 7 plus sine 4 theta over cos 2 theta plus cos 4 theta over sine 2 theta is equal to 3 cot squared 2 theta, which is now 7 plus, and as I say, all of this bit here is now going to be replaced by cosec 2 theta, which then equals 3 cot squared 2 theta. And then in terms of your knowledge of all, and there's a load to learn in trigonometry even, but one of the things you should know, for example, I don't know them brilliantly well, but I do know that cot squared and cosec squared are connected. So I know sine squared plus cos squared is equal to 1. I know that tan squared and sec squared are connected in some way with a plus 1. I know the same thing about cot and cosec. Okay, that they're connected there, because then I can go and look it up in the formula booklet if I need to. 1 plus cot squared theta is equal to cosec squared theta. So that will be true for 1 plus cot squared 2 theta then. Don't necessarily need to write this bit, but just to make it absolutely clear to the examiner. So I can now replace that for this bit in here, can't I? So if I'm doing that, cot squared 2 theta is cosec squared 2 theta minus 1. So that top line now can become 7 plus cosec 2 theta is equal to 3 lots of cosec squared 2 theta minus 1. Right, this is going to be a quadratic, which hopefully we'll be able to solve either by factorising or using the formula. Let's tidy it all up. So 7 plus cosec 2 theta is equal to 3 cosec squared 2 theta minus 3. Get it all over to one side and make it equal to 0. Gives me, just be aware of the fact that sometimes you're going to be writing down theta rather than cosec, rather than 2 theta. Just check back through each time. Make sure you've got everything right there. It's that minus the cosec 2 theta and then minus 10 equals 0. I would spend a little bit of time just checking to see if this does factorise. The examiners reverse engineered this to get this. They knew what they were starting off with, so it would not surprise me at all if this factorises down. Now, because we're doing P3 here, at this stage, there's some of the slightly more basic things that I'm not going to go through. You can look back on the channel and you'll find other places where I'll have explained how to do quadratic factorising, for example. But I'm not going to do them on every video that I do. So we get that. That's the factorising of it. So we get 3 cosec 2 theta plus 5 equals 0, which is going to give me cosec 2 theta equals minus 5 over 3, or we get cosec 2 theta equals 2. Cosec is 1 over sine, so this is the same as sine 2 theta then is 1 over minus 5 over 3, well that's minus 3/5, or we're going to get sine 2 theta equals 1/2. And what I've said about the quadratic factorisation holds true for this. I'm not going to spend ages explaining how to get the answer from this. If you're struggling to do that, go back, check through my channel, and you'll find other places where I've spent a little bit of time just explaining how to get these last 2 bits. So there are the answers. Just go back and check 3 significant figures where appropriate. So I did go back and check that. They are all done to 3 significant figures. You don't want to lose any marks on that last little bit here. Okay, hopefully that all makes sense.